An equation with one or more radicals containing a variable is called a radical equation. To solve a radical equation, you should do the following. First, you need to isolate the radical, and if the equation has more than one radical, you need to pick one of the radicals to isolate. Once you've isolated it, you need to raise each side of the equation to a power that's equal to the index of the radical you chose. Third, solve the resulting equation. If you have two radicals like we do in this video, we're going to have to do the steps all over again. You must check for potential solutions to the equation. So if one or more of your answers do not check out, meaning if they're false, it's called an extraneous solution and it has to be discarded. So for our first equation, we have square root of x squared minus x equals 12. Well, we have two square roots, but we have one on each side with no other terms without a square root. So we can actually do this all in one step. So we have both roots isolated on each side, and since they're both square roots, we are going to square both sides, which will cancel out the square and the square root on each side, leaving us with x squared minus x equals 12. From here, since it's quadratic in form, we're going to subtract the 12 over. X squared minus x minus 12 equals 0. And we're going to factor this quadratic, and this factors down to x minus 4 and x plus 3 equals 0. We get set both of these parentheses equal to 0, and when we do, we're going to get two solutions, x equals 4 and x equals negative 3. But do they work? Well, we got to plug each number in on their own back into the original equation and see. So let's start off with 4. We're going to do square root of 4 squared minus 4 equals square root of 12. 4 squared is 16 minus 4 equals square root of 12. 16 minus 4 is 12 equals square root of 12. And since root 12 is equal to root 12, we know that's true. So at the very least, we know that 4 is a solution. Now let's try out negative 3 and see how that works. Square root of negative 3 squared minus negative 3 equals square root of 12. Going to do the arithmetic on the inside. So negative 3 squared is 9. Double negatives will make a positive equals square root of 12. And then add the inside. So root 12 equals root 12. This is again a true statement. So we know that negative 3 also works. So you actually have two answers, a positive 4 and a negative 3 for this equation. Next, we're going to deal with square root of 3x plus 6 minus square root of x plus 6 equals 2. Again, we have two roots, but we also have a term without a root, so we're going to have to go through our steps a couple times. I'm going to isolate this square root first. So I'm going to add the square root of x plus 6 over to get it by itself. So square root of 3x plus 6 all by itself is going to equal 2 plus square root of x plus 6 over here. Since this square root is isolated and it's a square for the index, I'm going to square both sides. Now these will cancel, leaving you with a 3x plus 6, but this needs to be FOILed out or distributed out. When we do, we're going to get 4 plus 2 square root of x plus 6 plus 2 square root of x plus 6, and then plus x plus 6. Now it's pretty long and ugly, so I'm going to start combining all the terms I can. So 3x plus 6 equals 4 and 6 is going to give me 10. 2 root x plus 6 and 2 root x plus 6 is going to give me 4 root x plus 6, and then plus x. Now again, I'm going to isolate my square root, so I'm going to move the x and the 10 over. So if I subtract the x over, I'm going to get 2x. When I subtract the 10 over, I'm going to get minus 4 equals 4 root x plus 6. Now more or less this is isolated. I can divide the 4 over, but I don't want to deal with fractions, so I'm just going to leave it as is. Again, this is an index of 2, so I'm going to square both sides, which is going to, on this side, FOIL out and give me 4x squared minus 8x minus 8x plus 16 equals, and over here 4 squared is 16, and then the square root and the square for each other are going to just go away, so it's just going to be x plus 6. Combining and distributing, 4x squared minus 16x plus 16 equals 16x plus 96. Now, finally, no more roots, so I'm going to move everything over to one side, subtract the 16x over, subtract the 96 over, and I'm going to get 4x squared minus 32x minus 80 equals 0. I can factor a 4 out, so 4x squared minus 8x minus 20 equals 0. And I can factor my quadratic down to x minus 10 and x plus 2. So now, when I'm looking at this, I can set these two equal to 0, and I can discard the 4. Don't really need it. So I'm going to get x equals 10 and x equals negative 2 as my possible answers. But do they work? Let's find out. So positive 10 first. So I'm going to go plug it back into the original. So I'm going to do my work over here. Square root of 3 times 10 plus 6 minus square root of 10 plus 6 equals 2. 3 times 10 is 30, plus 6 is 36. 10 plus 6 is going to be, not 14, 16 equals 2. Square root of 36 is 6. Square root of 16 is 4 equals 2. And do the arithmetic. 2 equals 2. It is true. I am happy with it. So I know that 10 is a solution. Now let's do it again for negative 2. So square root of 3 times negative 2 plus 6 minus square root of 2 plus 6 equals 2. So 3 times negative 2 plus 6 is going to give me square root of 0 minus negative 2 plus 6 is 4 equals 2. 0 just goes away, so we don't need it. And then square root of 4 is 2, but it's a negative in front, equals 2. And negative 2 does not equal positive 2. So we can just get rid of it. This is not a solution, so we just X it out. And our only answer for this radical equation is positive 10.